Hi there, in this video we're going to learn how to build a machine learning model to detect whether or not a piece of text might be spam, and we're going to integrate that with Django and build a basic spam detection system that allows users to take comments on their website, send a request with HTMX, and then detect whether or not a particular post might be spam. And if they identify one as spam, they can then remove that post, and that will remove that from the DOM as well as the database. And if you want to follow along with this tutorial, there's some starter code on GitHub which is linked in the description. We're going to get started now, and we're going to start by building the machine learning model for this application. Now what we're going to do here is we're going to use this data set from Kaggle. It is spam data, and there's an emails.csv file, and this file contains text, which is the content of the email, along with a spam label, and it's 0 if the email was not spam, and it's 1 if the email was spam. So this is the label, and we're going to use that label to build a supervised learning model. We're going to build a k nearest neighbors model to detect or try to detect whether an email or any given piece of text is spam or not. So you can download that CSV file from Kaggle. Otherwise you can get it from the Git repository containing the starter code. It's in the data directory. We have an emails.csv file, and that contains all of the text and the labels. Now we also have in that directory a train model notebook. This is a Jupyter notebook, and we're going to use that to train our model throughout this video. If you're not interested in machine learning, feel free to skip to the web applications later in the video, but what we're going to do now is we're going to load up a Jupyter notebook, and we're going to build a model that can try and detect whether or not a text is spam. Now I'm using Anaconda here. I'm using Jupyter notebook. You can get Anaconda online. That's the easiest way, I think, to build simple machine learning models. And at the top here, we've imported the string module, and we've also imported pandas as PD. Now remember that this file is running within our data directory. It's this file here, train model.ipy notebook. And what we're going to do is we're going to load in this emails.csv file into a pandas data frame. So let's go back to our Jupyter notebook, and I'm going to paste some code here that's going to read in that into a data frame. And as you can see, we're calling pandas.readcsv. We pass the name of the file, and because it's in the current directory, we just need to put the name of the file here. And when we display the head of the data frame, you see we get a data frame with text and with spam, and these are the two columns that we have in our data frame. So what I'm going to start by doing is we're going to get the value counts in the spam. So we're going to see how many of these are spam and how many are not spam. And to do that, we index into the data frame in the spam column, and we can call the .valueCounts function, and that will return the number of values for all unique values in that particular column. So 4,360 are not spam, and we have 1,368 spam entries. So what we're now going to do is we need to pre-process this text. We're going to lowercase it, we're going to remove punctuation, and we're going to remove stop words from this text. And these steps will help you build a better model, because if a word has a capital S, for example stock, or a lowercase s, they should be treated as the same entity by our model. So what we need to start by doing is pre-processing our text to make sure that these kind of things are taken care of. So I'm going to create a new cell below the value counts, and we're going to import some stop words from Scikit-Learn. So if you don't know what a stop word is, it's basically a very common word that doesn't have a lot of real meaning. So words such as about, above, afterwards, they're words that don't really tell you much about a particular context within which they're used, so they're not really that useful for building things like spam filters. We're going to remove these from the text, and what we're going to do is we're actually going to create a function here, and it's going to be called preprocess, and as an argument that's going to take in a piece of text which is going to come from the text column of our data frame. Now the first step is we're going to remove the punctuation, and we're going to lowercase that text. So on a new line, we're going to reset the text variable that's coming in as an argument, and we're going to say it's a string.join, and to that we're going to pass a list comprehension. So we're going to say t.lower, which will lowercase the text, and we're going to apply that to each character in the text. But we also want to filter out the punctuation, so we're going to say if t not in string.punctuation. So string.punctuation contains all the punctuation characters, and we've imported string at the top, so we have access to that variable within the string module. And this line is basically going to redefine our text. It's going to iterate over each character in the text, lowercase that character, and it will filter out any characters that are punctuation characters. So once that's done, we can tokenize the particular text we've got, and what that means is we split up a sentence into an array of the distinct words in that sentence. These words are also called tokens. So I'm going to create a variable called tokens here, and it's going to be equal to text.split, and we'll split on the space. And this will have the effect of taking a sentence such as color printing, as you can see in one of the columns up here, and it will split that into an array containing 2 tokens, which is each individual word. So now that we have an array of tokens representing individual words, we want to now filter out the stop words. So I'm going to add a comment, filter out stop words. We're now going to return a string, so it's going to be a string with spaces, and we're going to join each of the words in the tokens array if that word is not a stop word. So it's going to be T for T in tokens if T is not in the English stop words. So that's our function. We're now going to apply that function to the text column of our pandas data frame. So we're going to redefine the text column to be equal to the current value of text, and we're going to apply a function to that. And we're going to pass a lambda function to apply. So for each text within the data frame column, we're going to pass that to our preprocess function. So we'll pass it on to that, and that will reset the text column after performing these pre-processing steps. So let's execute this cell, and when that completes we can add a new cell below that, and we can print out the head of the data frame. And if we view those changes, you see that we now have text that has been lowercased, we've removed punctuation, and we have also removed stop words from this text. So now that that's done, we're going to split this up into X data or featured data and our label data, which is simply the spam column. So I'm going to paste some code here, and we create an X and Y variable, and we simply index into the data frame on the 2 columns. The X data is what we're going to pass to the model. We want to train the model with this data in order to predict the Y value, which is a 0 or 1. So this is a binary classification problem. Now the problem we've got at the moment is that the X values are textual, they are strings of text. We need to convert them into numbers because the machine learning models that we're going to use, they only understand numbers. So what we're going to do is vectorize the text, and to do that we're going to use this vectorizer from Scikit-Learn. This is a TfidfVectorizer, and it uses 2 values, the term frequency, which is the TF part, and the inverse document frequency. And it's going to convert our raw documents, which is the emails themselves, the text. It's going to convert that into matrices of numbers. Now it's worth reading on how this algorithm works, but the term frequency part, that looks at each email, and it will look at all of the distinct words in that email, and it will find out how often each word occurred. Whereas the inverse document frequency, that will look at the whole set of emails, and it will figure out for each word how often did that word occur throughout the whole corpus of documents. So the term frequency tells you how common is a term in a given email, and the inverse document frequency tells you for a given word in an email and how many other or in what proportion of the documents did that word occur. So the inverse document frequency is a way to kind of measure how rare is a word. Does it occur in a lot of the different email contexts? So we don't need to understand this in a particularly technical way, we just need to understand how to apply the Scikit-Learn model, and it will transform our text into vectors. So if we go back to our notebook, we're going to have a new cell here, and I'm going to import that model from Scikit-Learn. And what we need to do is instantiate it. So I'm going to create a TfidF variable, and I'll copy the name of the model, and we can instantiate an instance of that model. And once we have that, we fit the model to the X data, which is the raw text from the emails. And after fitting the model, we can get some X vectors by calling the transform function on the TfidF model. So TfidF.transform, and we pass to that the X values. So let's execute this. And once that completes, you should be able to look at your X vectors. So it's a sparse matrix, and we can now feed that to a Scikit-Learn classification model in order to train a model to detect whether or not a piece of text might be spam. So when you're training models, you want to split your data into training and test sets. So what we're going to do first is I'm going to import a utility from Scikit-Learn called train test split, and to that, if we paste some code in here, we're going to pass the X vectors that we got from the TfidF model, we're going to pass the Y labels that we have, and we specify a test size of 0.2, which means that 20% of the data will be used for testing the model and evaluating the model, and the other 80% will be used to train the model to detect the patterns in the data. Now this train test split function, it returns a tuple of 4 values. It splits your X data into XTrain and XTest data, and it splits the Y labels into YTrain and YTest. So we can now train the model with the X train data, and we'll pass the Y labels for the training set. And then later on we'll evaluate with the X test and Y test. So if we execute that, we get back the shape of the X train and the Y train labels. You see that the X train data has 4,582 rows and 37,000 columns, and that's one for each distinct word in the email dataset. And the Y train labels, you can see 4,582 instances, and that'll just say 0 or 1 depending on whether each instance of the training set was spam. So what we're now going to do is we're going to train a classifier. So I'm going to import the k nearest neighbours classifier from Scikit-Learn, and we can instantiate that below with this line here. So we have a variable now called knn classifier, and to that we're going to call the fit function, and we pass the X training data, and we'll pass the Y training labels as well, and that's going to learn a model, and as the name implies, k nearest neighbours, it's going to look at the nearest neighbours in the vector space for each of the instances, and it will classify based on what the labels of its nearest neighbours are. So execute that cell and we'll get back the model. So in a new cell, what we're going to do is we're going to predict some instances. Now we have a test data set, so what I'm going to do is call the classifier's predict function, and we'll pass the X test instances to that, and that will give us back predictions for all of the 20% of the data we used for testing. So if I execute that, we get back an array of labels, 0 where it predicts not spam, and 1 if it predicted spam for that particular text. And what we can do is we can evaluate the model properly using some functions from the Scikit-Learn metrics module, the accuracy score, the recall score, and the precision score. So if I print out the values for that in the cell below here, you see we have an accuracy of 97% for this model, whereas the precision was 98% and the recall 91%. These are pretty good metrics for this model. Now I'll leave a link in the description as to what these actually mean. The precision and recall in particular are very important when you're evaluating a model. But what we're now going to do is we're going to serialize the model and save it to a file so that we can load it in our Django application. Now there's a section in Scikit-Learn's documentation for this. It's called Model Persistence, and you can serialize using the built-in pickle module, or a better way is to use joblib, which comes with Anaconda. So what we're going to do is dump the model to a file, and we're going to do this for both the k nearest neighbours model that we've trained as well as the text vectorizer, and that's the TfidfVectorizer. So what we're going to do at the bottom, we'll create a new cell and we'll import from joblib the dump function. And we're now going to dump the two models from Scikit-Learn that we have here, and that will then create two files within our data directory. So if we go back to the Django application, we now see in the data directory with our Jupyter notebook, we also have a spammodel.joblib file and a tfidf.joblib file. Now the idea is we can load these in our Django app, and we can then pass text to these models in order to classify it as spam or not spam. And that's what we're going to do now. So what we have to do is first of all create a virtual environment, and we're going to install these requirements: Django, joblib, and Scikit-Learn, as well as Django extensions. And you can run the pip install requirements.txt command in order to install all of these in your environment. So what we're going to start by doing is adding a comment model here. So within the core models.py, we're going to create a comment model. And remember, the purpose of this video, we're going to have comments on a page, and we're going to allow admin users to find out whether or not a model predicts these comments to be spam, and then allows the admin to delete the comments. So what we're going to do in the file here, we're going to import Django's user model, and we're going to create a comment model here below that. So that will inherit from models.model. And this model is going to have three fields. It's going to have the text, that's the content of the comment. It's also going to have a foreign key to the user who posted the comment. And it's also going to have a time, that's going to capture when the comment was added. And once we've added that, we can run the make migrations command. And that should add that model to our migrations, and then we can run migrate to add the table to the database. Once we've done that, we're now going to build a comments page in this application. Now normally comments would belong to a post, but we're just going to have a page where anybody can comment. Not the best practice, but it's going to do for this tutorial. So what we're going to do now is we're going to go to views.py, and we're going to add a view here that will list all of the comments. So at the top, we're going to import the comment model that we've just created, and we're going to create a function called comments. We'll just do a function-based view here. It will take the request, and it's going to fetch all of the comments from the database. So that will be comment.objects.all, and then it's going to return those comments within the context to a template called comments.html. Now if we look at the templates directory, we have comments.html. Let's render out those comments in a simple tag here, so we're only going to see the query set, and we'll see if that works. But first of all, let's also add a URL. If we go to urls.py, to our URL patterns, we're going to add a path that will link to that comments function that we've just created. And once we've done that, we should be able to run Django's development server, and we're going to be able to have a look at the comments on the page. So that will load up this query set, and as you can see, it's empty. There are no comments in our database at the moment, so we're going to add those now. In order to do that, I'm going to go to the admin interface. So we're going to register our comment model with the Django admin. So at the top of this page, let's import that model, and we can then call admin.site.register, and we'll register the comment model. Once we've done that, in order to access the admin interface, we need to create a super user. So let's stop the server, and we'll run the python manage.py create super user command. We can call this admin, and we'll give it a password of test as always. Once that's created, we can run the server, and we'll go to the admin interface on the page, and you can access that just with the /admin endpoint, and we can log in with our new user. So we have the comments model here on the left hand side. If we go in there, I'm going to add 5 or 6 comments here, and the idea is that some of these comments will be spam and others won't be, so I'm going to add those now. So we now have 7 comments in our database, and you can see that some of these, such as this no more monthly bills one, are probably spam, whereas other ones such as this one are probably okay. So if we now go back to our page here, our comments page, you see the query sets rendered with our comments. Now we want to improve the styles here, so we're going to use Tailwind to do that. So let's go to our template here, comments.html, and we'll replace this with this code here. We have a header class with just comments there, and then below that we have a div with an ID of comments, and we have a for loop here that lists them out in an li tag. So if we save that, we should see that this is improved a little bit, but still not very good. So what we're going to do to improve this is we're going to look at this Tailwind card here, and I'm going to modify this, but you can get the basic code from this show code section here, and you can just copy that. What I'm going to do is copy a modified version of that, and you can see we're looping over each comment in the database. We display the text as well as a button that allows us to remove a particular post. So if we save that and go back to the page, we should now hopefully see that this looks a little bit better. So we have the comments listed out nicely here, along with a button that later on we'll use HTMX to remove a comment. Now one thing we want to do is we don't want to just allow any user to remove a comment. It should only be admin users that are allowed to do this. So we're going to go back to the template here, and this button that says remove post, we're going to surround that with a template if statement, and we're going to check if the user is a member of staff, so the isStaff boolean on the user model. If that's true, we will render the button, otherwise we don't want users to see that. Now by default, I'm logged in as an admin user because we accessed the Django admin, so we will still see those buttons, but a normal user will not. And to demonstrate this, we're going to go to the Django shell here. So let's go to shell plus, and what we're going to do is we're going to change that isStaff to false. So we can get the user with user.objects.get, and we pass username equals admin there, and that's who I'm currently logged in as. And then we can set the isStaff flag to false and save the user model. So now if we exit that and run the server again, we should now see that the buttons do not appear because the user is not a member of staff. So that works fine. I'm now going to make this user staff again, and you can see the buttons have returned. So what we're now going to do is we're going to add a button at the top here that allows admin users to run the spam detection model. So back to the template at the top, just under the H1, I'm going to add some HTML here, and we'll format that. So if the user is a member of staff, we're going to create a button with the message detect spam, and if we save that and go back to our page, we see this button here. It's rather crudely placed at the top, but what we're going to do now is we're going to wire up HTMX. We're going to call the backend, which is going to load up our machine learning model and run the text for all of the comments through that model, and we can try and automatically detect whether or not something is spam. Now in the project's base.html, we are loading HTMX. So from the starter code, we already have HTMX loaded. So in the comments, we can wire up the request in this button. So to the button, we're going to add an hx get request, and we'll use the URL template tag here, and we're going to call up a URL, and we'll call this URL check spam, and we'll create that in a minute. We're going to set the hx target equal to the div with the ID of comments, so the ID of comments, and that is actually this div here below containing all of the comments on the page. And we're going to say we want to swap that into the outer HTML of our target div, and that will replace the entire div. So the next step is we need to add this check spam URL to the urls.py file. So below our other URL, we'll paste this. We call it check spam, and that's the view we need to create here in the views.py file. So we'll go back there and we'll create this view within here, and it's going to take the request as an argument. And for now, we're just going to return a partial containing all of the comments. So I'm going to copy the code from here and paste it in, and we're going to change the template here. And the template we're going to load up is partials/comments spam, which we're going to create just now. So let's copy the name of that, and we have a partials directory under the templates. So we'll create a file here called comments-spam.html. So what we want to add here is the div that we're going to return from our HTMX request, and it's going to contain all of the comments. So let's copy this div here with the ID of comments, and we'll paste that into our partial here. And what we're going to do now is return this after checking whether or not each comment is spam. So in order to check if it's spam, we need to actually load up our model and run each comment through that model to check whether or not the model thinks it's spam or if it's fine. Now in order to do this, I'm going to create a new file in our core application. It's going to be called spammodel.py, and we're going to add a few imports at the top here. The string module, we're going to import the settings from Django, and from the joblib library we're going to import the load function. Now remember, in the Jupyter notebook we used the dump function from joblib to serialize the model to a file. In this case, we're now going to use the load function from joblib in order to load it into Scikit-Learn model again. And finally, we also import the stopwords from Scikit-Learn. So now that we have the imports, let's set two paths to our files here. Now the k-nearest neighbours model, that is defined by this link here. We look at the base directory, and within that we have a data folder containing our spammodel.joblib model. And similarly for our vectorizer, we have this TfidfVectorizer at that location. Now we need to load these into proper Scikit-Learn models, so I'm going to say knn, and we're going to set that equal to the load function, and we'll pass to that the knn model file. And similarly, we're going to say tfidf equals load, and we'll pass the vectorizer file to that. And that's going to load these into the Scikit-Learn objects that we use to actually classify each piece of text or predict over a piece of text. So the next step, I'm going to copy the preprocess function from our Jupyter notebook, and that was the function up here that takes a piece of text and it processes it in order to convert it into a better format. So we'll copy that and we're going to paste that into this file. Now arguably you should have this function in its own file and it can be imported in both places. For now we'll just copy it. And the final thing we're going to do in this spammodel.py file is we're going to create a function that is going to classify the comments. This function is called predict spam, and it's going to process each document or each comment, and it will predict whether or not that's spam. Now the argument to this function is going to be a list of all of the comments, so different comments in our database. What we're going to do is we're going to create a variable called processed, and we'll pass each comment through this preprocess function above, and that will lowercase it, it will remove punctuation, and it will remove the stopwords as well. Once we've pre-processed that, we're going to create the vectors for each piece of text. So let's create a variable called vectors, and to generate the vectors we use the TfIDF model that we've loaded with joblib, and we call the transform function of that model, and we pass to that our processed bits of text. So that will take the text, it will create vectors. The final step is to get the spam prediction for each of the vectors representing the comments. So what we're going to do in order to do that is use the knn models predict function, and we pass that the vectors that we've got above, and we can return that to our caller, and that's basically going to return a numpy array where 0 represents not spam and 1 represents spam for each of the comments in our database. So this function here uses the utilities we built in the Jupyter notebook, and it will return a set of predictions for all of the comments. So let's now return to our view, and we're going to call that function within the check spam endpoint. So at the top of this file we're going to import from the spam model module, that's predict spam function that we've just created. And for each of the comments in the view, we're then going to get a set of predictions by calling predict spam. And what we need to pass to that is a list with all of the text from the comments. So we're going to use the comments query set in the line above, and we'll call the values list function on that, and we'll get the values for the text. And if we specify the flat equals true keyword argument, that's going to flatten that into a Python list, which we then pass to predict spam. This function here will process each of the items in that list, transform them into vectors, and then generate a prediction of whether or not that particular text is spam or not. So if we now go back to the view, if we print out the predictions for each of our comments, we should see hopefully a NumPy array here. And we can go to the front end and test this out. If we go back to this page here, I'll refresh and we click detect spam. On the terminal we get back an array here, and it has 1 where it thinks it's spam, 0 otherwise. So this is working fine. The model's being called and it's predicting for each piece of text whether it thinks it's spam or not. And you can see when we call detect spam, the HTMX request is replacing this content with the same content, and that's because in the partial we've just copied the div with the ID of comments, and that renders out all of the comments. What we're now going to do is distinguish between spam and not spam, and we're going to render these slightly differently if they are spam. So we need to know for each comment in this comments list that's returned as part of the partial, is that comment spam or not? So what we're going to do is go back to the view. We have comments and we have predictions. These are the same length. Each comment has a prediction. So what we're going to do is we're going to zip them up using the zip function in Python. So to the context, we've got comments. I'm going to call the built-in zip function, and we'll pass the comments to that along with the predictions. So if we go back to the template now, when we iterate over the comments, we can get the comment as well as the prediction by unpacking it like that. And we're going to render something different if the prediction is 1, because that means it's spam. And if it's 0, that means it doesn't think it's spam. So we want to render this slightly differently depending on whether or not it's spam. So let's first of all check whether the prediction is 1, in which case it's spam, and this will evaluate to true. What we're going to do in that case is we'll change the background color to red of the particular card, and that way the admin user, when they click this detect spam here, they know which one is spam because it's a red background. And similarly, the ones that are not spam, we want to use an else block here and we'll render them in green. So let's copy this div and we'll create an else block below, and we can paste that in here and then end the if statement. So we don't necessarily need to do this in an if else block. We could do some conditional rendering, but if you want to make many customizations, this way is better, I think. And for the case where we hit the else block, we know it's not spam, so I'm just going to render that as green, and we'll make it green 400 here. Now these are tailwind styles that you can put in your class. So now that we've added those, let's go back to the page and see if this works. If we refresh and hit detect spam, you now see, and the colours might not be brilliant here, but you can quite clearly see which ones are spam and which ones are not. And the button styles are a bit messed up, but we're not going to fix that at the moment. You obviously wouldn't want to leave the button with that colour though. So this is quite interesting. We hit one button here and HTMX sends a request which loads a machine learning model and runs each comment through that model to detect whether or not it's spam, and it returns re-rendered content to the front end. Quite interesting, and what we're now going to do to close off this video is we're going to allow users to remove posts that have been flagged as spam or otherwise, and we're going to do this by adding some HTMX attributes to our remove post button. So we need to add this to these buttons here in both the original template and the partial. So what we're going to do is add an hx delete request to these buttons. So it's going to be hx delete, and it's going to go to an endpoint called delete comment, and it will pass the comment's primary key, allowing the correct comment to be deleted. And we need to add that to all of the buttons throughout our templates. So in the other block here, we have another one. We're going to add it here as well. And we're also going to add that to our original template that contained the button here. So if we scroll to the end, and we can paste that here. So now all of our buttons have these hx delete attributes with a delete comment endpoint. We need to now create that URL and that view. So let's start by creating the URL, and we'll do that here. And we're going to pass the comments / primary key of the comment, and that will load a view called delete comment. So let's go to views.py and we'll create that view now. And it's going to take the request, but it's also going to take the primary key, which if we look back, we've called that PK. So we can define that in the view as an argument, PK here. And what we're going to do in this view is we're going to delete the comment and then return a partial containing all of the comments. So before we write this view, let's import a couple of things. We're going to import, as well as render, the getObject or 404 function from Django.shortcuts. And we're going to import the HTTP response class from the HTTP module. Now let's write the function. We're going to fetch the comment by the primary key that's been passed in, and we'll use getObject or 404 for that. The model is comment, and we'll search based on that primary key being equal. If we find the comment, we can then call its delete method to remove it from the database, and then we're going to return an HTTP response with a status code of 204. And we can go to HTMX's documentation here and to the request and response section. And what we're going to do is we're going to make HTMX ignore the content of a response by returning a 204 status code. This stands for no content. And once we return that 204, HTMX won't perform any actions, but what we're going to do is write a bit of JavaScript using HTMX in order to delete the correct block from our comment section. So for example, if we deleted this post, we're not going to return a partial, but what we're going to do is we're going to capture the event, we're going to figure out which row is to be deleted, and we're going to remove it from the client directly. And the main benefit of just removing it from the client is that we don't need to rerun the machine learning model, which can be quite a time-consuming process. Instead, we can just remove the row from the client. And HTMX does actually have some tools for client-side scripting as well, kind of similar to jQuery. So we're going to see very basically how to use those in a second. Now before we can test this, there is one thing we need to do. We need to go to our base.html, and we're going to replace the body tag here with a line I've got here, and that's basically going to use the hx headers attribute to attach the CSRF token, and we need to do this when we're sending a delete request because that's regarded as an unsafe method. So if we save that and go back to the page, we should now be able to see that we can remove a post. Now nothing happens on the front end because we're returning that 204, which doesn't actually do anything to the DOM. But if we refresh this page, you can see that that comment is now gone. So what we now need to do is use HTMX's client scripting tools to actually remove the row when we delete an element. So what we're going to do is we're going to go to our comments.html, and we're going to add a script at the bottom here, and that's going to define some client-side actions that are going to occur when a request has been sent with HTMX. And we're going to find out when a request is finished, and we can use HTMX.on for that. And the event that we're going to listen for is the HTMX after request event, which happens after a request is completed. And then we can write a function here that will perform the actions we want to happen after the request. Now one thing we can do is we can console log the event here that is passed into the function, and we can see what happens when we send these delete requests. So if we load up the developer tools, we can go to the console, and when we refresh this page and we do a delete event, you see that this custom event is put on the console. And one of the attributes on the event is this detail attribute, and we can see from that that the request configuration has a verb of delete. Now that's the one we want to capture. We want to get the delete event, not the get event, which occurs when we detect the spam. So we're going to set some code up to listen for that event and to perform an action when that occurs. So we're going to take this e value, we're going to follow it through the detail, request config, and we'll get the verb. So what we're going to do is write an if statement in JavaScript, and it's going to be if e.detail.requestconfig.verb is equal to delete. If that's true, what we want to do is remove the row that triggered that event. Now we can also get from this event another attribute called ELT, and we can actually go to HTMX's documentation here, detail.ELT. That's the element that actually dispatched the request. So this is kind of like the source element, which is the button itself. So when we hit a button to delete a post, this is going to be the source element. This is going to be what this ELT is equal to. So let's pull that out of the event. So I'm going to set a constant called source. It's going to be e.detail.elt. And what we want to do here is we want to remove the card that contains that button. So we want to find the closest card in the DOM to this particular source element. So if we look back at the developer tools, if I was to inspect this element, you can see that it's this card here, this class of flex call M3 that we want to remove. We want to find the closest one of those to our button. And HTMX has a closest function that you can use for this. So I'm going to paste that in here. And the card that we're looking to remove is HTMX.closest. We find the closest element to our source button containing this selector here, which is the div with that class. And when we find that, we can simply call HTMX.remove and we can pass our card to that. And that should remove it from the DOM. So if we now save this and reload the page, we can detect the spam. I'll just remove the developer tools here, and we can now remove a post, and that will remove from the DOM. And you can see that the elements are preserved, the colors indicating whether or not they are spam. These are all preserved, and this all works fine. And when we refresh the page, we can run the model again, and that all works fine as well. So this has been quite a long video. We've learned how to build a machine learning model to detect spam. We've learned how to use HTMX to call an endpoint that loads up the model and passes text through that to try and identify what is spam and what is not. And we can see how we can render different responses, different colors to indicate whether or not things are spam to our users. And in this video as well, we've also seen some of the scripting options available in HTMX. Kind of similar to jQuery, we can listen to events, perform actions, manipulate the DOM, and we can use that to simply remove an item on the client rather than sending a request to the server and getting a partial. In this case, that's useful because we don't need to rerun the machine learning model to generate the background colors. Instead, we can just remove the row and we're done. We can do it all in the client, so that's quite useful to know about as well. So thank you for watching. If you've learned something in this video, please like and subscribe to the channel, and we'll see you in the next video.